Good morning, good evening, and good afternoon, everyone. And welcome to this new tutorial on MapReduce. Now, in previous sessions, we have already discussed on how MapReduce works, what is its architecture, and what is MapReduce programming model. We have also learned on basically understanding what Yarn does when it comes to resource allocation for your processing needs. Now, in this tutorial, we will have some demos on running a MapReduce and processing data to solve some real-time business problems. Now, I have set up some code in Eclipse which can be either tested on your Windows machine by running it in a local mode or packaging your code in jar, transferring it to your cluster, and then basically running it on your cluster nodes. So we'll see both of these examples. Now let's assume and let's understand about a problem. Say for example, we have a telecom based company which would want to process its data. Say it would want to find out the number of subscribers and the kind of calls they are making. Or for example, let's imagine a online website or a music website where users listen to various tracks. The data gets collected and then basically it has to be processed. So imagine you have a company which is hosting music online, and you have users who either are subscribers or basically create their accounts, listen to different tracks, and then basically use these services. Now, what if I would want to process such data? For example, if I would want to find out what is the number of unique listeners, or number of times the track was shared with other users, or number of times the track was listened to on the radio or in total, or even was skipped on the radio. Now in that case, I would want to process the data to find out information. So we will solve this kind of problem using the MapReduce programming model, the MapReduce approach, which as I explained earlier goes for mapping and then goes for reducing. And in between it has different phases, that is shuffling and sorting. You have your partitioner phase, you have a mini reducer which is your combiner phase, although all of these intermittent phases are taken care by the framework itself. The developer or the person who is developing the solution is responsible to work on the mapper function and the reducer function. Now for that, we can basically be writing our code to process this data by giving a mapper and a reducer function. Data, we can look into example and say for example, let me pull out some data here. Let's look in say some files I have, and for example in this case it would be this kind of data. Now that magnitude could be anything, right? Now here I have the data which the first column talks as the user ID or the membership ID. The second is the track ID. You have then your if the track was shared online. The fourth one is number of times the track was listened to in total, and the fifth one is if a particular track was skipped. Now I could have this data in huge numbers and then I could be processing it, but we will take a simple small example to understand how MapReduce does this. So this is a file which I have already uploaded on the cluster and which will be as my input file. Now let's look at the code. So what we would need is, for this kind of processing, we would first need to understand the data. Now here the first column, as I said, is user ID and second one is track ID, which can then be used to basically process the data. We need to write a mapper class which would emit the track ID from this data. So I have it here, and let me also open up a constant class for this, which is here. So as I mentioned, we will have to write a mapper class which would emit track ID from the data and user IDs with some intermediate key value pairs. Now that is what your mapping phase does. It works on the input splits. It basically does the mapping and it gives you a list of data elements which are nothing but your intermediate key value pairs. To explain it in a simple way, I would say just let's work on this data sequence. So let's create a constant class as shown here. So this is my package. Now I create a class called last fm constants, and then I am here declaring some variables with some constant values for each of the field which I just showed in the file. You have user ID, you have track ID, you have is scrobbled or shared, radio, and is skipped. Now these are my constant which will be used while I process. Then we will have to work on a mapper class which could or which would emit intermediate key value pairs, that is your track ID and user ID. Now how do we do that? So here is an example. So we basically would have a mapper class as it's seen here. This is my mapper class which will be used to process or do the mapping phase. Now here we have the class name which is unique listener and unique listener's mapper which extends the mapper class. That means I would have to import the relevant packages for my code, which I've done on the top. Here then I have variables, that is track ID, user ID, which use int writable. So Hadoop has its own data types, say int writable, long writable, boolean writable, which are similar to what you have in Java as int, boolean, long. But these data types which are used by Hadoop are basically an implementation of writable and writable comparable interfaces. So those are two interfaces which are then responsible for these classes which we are using as data types in our code. Here we start our map task, which would then consider key, which is an object, value as in text, and then you have your data types, that is int writable, text, and object. We are also handling exception, and then what we do is we work on the file. So we would split it based on the delimiter. Now in my case, the delimiter is a pipe. Then what we do is we set for the track ID using our constants, that is what we have seen here, which is for your user ID, track ID, and so on. And we do the same thing for our user ID. We look into the values and then we basically emit out just the track ID and user ID. That would be my intermediate key value pairs. Now here I am also using a counter named invalid record count. Now that is mainly to count if there are any invalid records which do not exist in the file in an expected format. Now, we don't do this in case of invalid records. If we don't do this, what would happen? If we had invalid records in our file, then our program might fail. And that's the reason I'm using counters.invalidRecord.count, and I'm going to use it for my mapper. Once we have our mapper written, which basically will look into the file and emit the track ID and user ID, then I would write my reducer class. Now this is how my reducer class looks, where I'm saying public static class unique listener reducer, which extends reducer class, and then the data types which it would need. So int writable for the values which it works on. So our reduce task will work on track ID, and this reducer class is to aggregate the results. So we cannot directly use some reducer as the records we are getting are not unique. The records might be duplicates. It might be the same user with the same membership ID listening to a different track or sharing it. And we cannot be just using a generic reducer. So here we work on the reducer, and this is how my code would look. So what my reducer does, it basically would help me in solving the problem, such as basically aggregating and counting the number of tracks which were shared or listened to, or overall the number of tracks, and then you have your tracks which were skipped. One of the main tasks of your reducer class is on working on the intermediate data which is created by your mapper, or you can say multiple map tasks which would be running on multiple splits on one or multiple nodes, and your reducer's work is to aggregate the result based on the keys. Here we are using set to eliminate duplicate user IDs. Now, once we have written our reducer class, which basically works on the user ID set, it eliminates the duplicate user IDs, and then it basically gives me a count of the track IDs in an aggregated way to solve my use case. Once I've done that, I also need a driver class which basically tells about my overall code. So here we are having a job configuration where I say my name of the job could be unique listeners per track. I'm setting the jar by class, calling it as unique listeners. That's my class. I'm mentioning my mapper. I'm mentioning my reducer. Now, if you notice, I'm not using a combiner class. For this use case, we would not need that. So combiner class is a mini reducer which basically helps in reducing the data or aggregating the data before it reaches the reducer class. I am also talking about the key, which would be using intritable, and then the value, which would also be intritable, as all my values are in numeric. If I had my key in something else, or if I had names instead of user ID, then I could have used text class. I also specify what would be my input and output path, which will be specified as an argument, and then basically I am printing out number of invalid records. So this is my MapReduce program to work on solving our business use case. Also notice I'm using the relevant packages which are being used in the code, and for these packages and for my this code to compile, we need to make sure that we have added the right dependencies. Now you could have created your code with POM and using Maven, or based on the classes what you are using, you can always add the jars, the relevant jars to the build path. So here we can look at the build path what I have, and we can see what jars I have used. So the main ones are your commons. I have Hadoop core. Now you can ignore Hive or JSON which I have here. Those are for different applications. So the main is common CLI and Hadoop core, depending on what you are using within your application. So that has to be added to your build path. Also, we are having the Java 1.8. Now, if I wanted to run this application or test it on my local machine, I could have also set up the configurations. However, it is preferred to run the code on a yarn based cluster. If you would want to try it on Windows, then you can always go to the run configuration. You can basically specify your application which you would want to run. You can then say what is your class name. You can be passing in your arguments here, and in your environment you can specify Hadoop as a local IP. However, I suggest package it as jar and run it on a cluster. So what you could do is you could select your class. Now my unique listeners.java class is also getting the constants from last FM constants. So both of them belong to the same project, and I'm using that here for my mapper and for my reducer. So in mapper, I refer to last FM constants, where I've given constant values for all of these fields. Once you have your code ready, you can always package it as jar by saying export and select the jar option in Java, click on next, and then you can select your project and give it a name. So I'm pointing into a different jar file, but I can do a browse. I've already packaged it as jar, and you can see I have a jar here. So I can select this, I can say save, and that would be my jar. If I'm making some changes, it will anyways overwrite it. Once you have your jar ready, what you need to do is place it on your cluster. Now I have already done that. I have a cluster here. Let me bring it up, and what we can do is you can use different ways. You can have an Apache cluster, you could have a Cloudera cluster, wherein you need to place. So let's get into this. Now here I'm using a already set up lab environment. You can be doing an FTP. You can upload your code using Hue. I have done an FTP from my local machine and uploaded it to the cluster. I could click on web console, which basically gives me a console to try out things. You could, as I said, you need the jar, and then you need to push your jar to your cluster. Let me log in here, and once I'm logged in, I am on a edge node, which allows me to connect to a cluster which is Cloudera's based, and now I can check on my HDFS path in my user directory. I should have multiple files and directories, and in one of the directories I have placed in this file. So we can look in here, which is sample mr in, and that's my directory where I have the input. So I can look in sample mr in, and the same file which I showed in the beginning, I have uploaded it here, which is the listeners file, which we can even check. So I can say listeners.txt, and I can even do a cat. So this is the file which is already existing here, which has the content which we spoke about, although not huge content. but it is more than enough for us to test our code, and obviously we can upload huge data and then have the same MapReduce program helping us in answering our questions. We also need the jar file, and the jar file should be here, which I have uploaded. So I need to run this. Now to run your MapReduce, you can say Hadoop jar. You will give your jar name, which is this one. Now I need to give my package name with my class name. So I'll say org example Hadoop codes, and then I need to give my class, which is unique listeners. Now if I hit enter here, it will ask me to give an input and output as my code says to pass in the arguments. So we will pass in the arguments here. So I'll say my directory where I have the data. Now I could be picking up one file or multiple files to process this. So I will say just one file, which is here, and that's my file, which is sample mr in. That is what I want to use. So I'll say sample mr in, and I need to give my file name. So I can say listeners.txt, and then I can give an output which will get created when you run your MapReduce. So I can say sample mr, and then I can say output 1, and this is the directory which will get created, which will have my output. Now you can run this job in this way. You can even run it in a local mode by specifying arguments on the command line. You can give different kind of properties. If you want your MapReduce jobs output to be in a compressed format, you can do all that. So let's run this, and this should connect to the resource manager. The job is processing one input file. It will start with the mapping phase first. Now it looks that the job has failed due to some reason. Let's have a look. I just looked into the job and I realized why it failed. The main reason was I was trying to write an output in the directory to which I don't have access. I need to have access to write the output in a directory to which my user ID has permissions. For this, we will have to submit the job again with the right path where it can write the output. So we can do this. This is my class. I need input. So I'll say, and then we can say sample mr in, and I'm looking for listeners.txt, and I need to give an output which should be in this path, and then we can say sample mr output 1, and then submit the job. Now once I've submitted the job, as I said, it has one input part to process. It is working on one split because the file which we are trying to work on is smaller than the block size. It goes for the mapping phase, and then it goes for reducing, and it's done. So if you carefully look at the MapReduce output here, it says the number of outputs it had to process was just 4. So every line by default is considered as a record, and we had totally 4 lines. The output is basically working on again giving you 4 records, right? Because we are doing a split based on the delimiter. Then this would become an input to combiner if we had a combiner class, but we don't use that. So the output from your map goes to the reduce, which will basically work on the input records and create output records. Now we can have a look at this, the output of this job, which is stored in HDFS, and I can either be giving a complete path, or I can just mention the directory which I used, and that should by default take me to the directory which should have my output. Now based on how many reduce tasks were used, you will have number of part files which show up here. So we have one map and one reduce task. That could have controlled, or that could have been controlled by giving things on the command line. So here I have run it in a yarn mode, where yarn was used to allocate resources for my applications, and we can always check that on the yarn UI, or also by going to say Cloudera Manager if that is available. If you're not using Cloudera's cluster, then you can always in Apache cluster go to your yarn, and you can go into the UI wherever your resource manager is running. So that is one option. Or if you have a Cloudera cluster, you can look in applications, which will show all the applications which were recently run. So this was the thing which failed earlier because of permissions, and this is the one which succeeded. Now I have a job ID which can always take me to the yarn UI, the history server, where I see how many map and jobs were run. And for further information, you can always go and look into the map and reduce tasks. So this was a map task which ran, happen within a container which was allocated by your yarn, and we can also look on the node and logs what really happened. You can also look into the reduce task. You can also look at the counters which we were seeing on the command line on how many map and reduce tasks, how many bytes were read, what was the garbage collection time, how much CPU time was spent in milliseconds, and you get all the counters here. You can specifically be looking at counters for map or for reduce. So your yarn UI helps you to look into for more information. Now if I go back to my console and I have the output file, I can basically look into it by selecting the output file, and I can do a cat, which basically will show me what is my output. So this is my MapReduce, and basically what it has done has it has aggregated and pulled out the information for your different listeners based on the data what we have provided. Let's look at one more example of using MapReduce programming model to solve a real-time business case or a problem. Now the problem in hand is that we have some data collected from a telecom giant, and basically we have some sample data here which lists the list of subscribers which are using the services. Now if I look into the file, I have call data records, which basically gives me information about the data collected by a telecom company. So this telecom company keeps records of its subscribers, and it calls this particular file as call data records. Now what does this call data records contain? It basically has a from phone number as the first field. It has the to phone number, that is call being made to a particular number. Then we have the call start time following a timestamp. You have a call end time, and then we have finally if this call was a distance call or what we call as STD call. Now what we need to do is we need to use our knowledge of MapReduce. We need to use the MapReduce programming model, and we need to come up with a code to find out all the phone numbers, for example, who were making more than 60 minutes of STD calls. Now here the flag 1 basically means it was an STD call, and 0 means it was a local call. How do we do that? Using MapReduce. So this is again a problem where you would want to count through the data, and you would want to aggregate the values to come up with result. So let's look at a sample code for this one. So here I have my Eclipse, and again like a previous example, we are having a class which declares some constants for the fields. So you have phone number with 0, phone number with 1, call start time, call end time, and an STD flag. So these are the constants which I would be using in my code, and here is my main class which will use the MapReduce basically to solve this problem. Now I'm importing the packages, and as I explained earlier, these packages are mainly to make sure that we can use the classes in our code in the right way. So here now the order of your driver class or your mapper and reducer does not matter, right? The first thing what we need is we need a mapper which will do the map task. So here I'm creating a mapper which is tokenizer mapper, and that extends your mapper class. It accepts the data types, that is object, text, and long writable. As explained earlier, these are your data types which are Hadoop specific, and data types like int writable, long writable, boolean writable, and many others depend on the writable and writable comparable interfaces. Now here we start with taking up our phone number. We basically also take duration in minutes, so these are the variables, and I'm using the appropriate data type for those. Then I start writing my map task. Now what does my map task do? It basically works on the string which we have, and it breaks it into individual elements based on a delimiter. Once that is done, then we are also checking if that particular string which we are looking for has a STD flag, because we would want to find out how many customers or how many of them were making phone calls which were more than 60 minutes, and if these calls were STD calls. Then basically I work on the phone number, and I set it using the CDR constants, for which we have already created a class using the phone number, call end time, call start time, and I also compute or calculate the long duration. because we need to find out the calls which were more than 60 minutes. Finally, we extract the phone numbers and the duration of the call made by a particular phone number. So this would be my mapper giving an intermediate output, which would then have to be sorted and shuffled and then handed over to reducer. What does my reducer do? It uses the right data types. It basically starts with a sum as 0. It would look into all the keys and values, and wherever it would find keys which are repeating and the duration is more than 60, it would give me an aggregated result. This is my reducer. And finally, we have a driver, as I explained earlier, which has job configuration, your mapper, reducer, and also we are using, just as an example, a combiner class which does not have a class of its own, but it is basically using the same reducer class. Once your code is ready, check if it compiles, check if you have all the dependencies met, and package it as jar, transfer it to the cluster, and run it with or on top of yarn. So what we can do is, I have already moved it here and we can look into this machine. I already have my jar file, which basically also needs a input, which I have already pushed to my cluster. So we can look in for the file which should be existing in sample mr in directory, which is within my user and my name directory, and I have the call data records, which basically shows the data which I was showing in the notepad file. Now I can say Hadoop jar and point it to my jar, which is std subscribers jar. We need to use the package, so I'll say org example Hadoop codes. That's my package, and my class name is std subscribers. So I will say std subscribers dot, and then you need to give your input. So we will say sample mr in, and I will give in a particular file which is call data records .txt, and then we can point it to an output directory which will get created automatically. So I will say output 2, and that should have my result. And like we ran our first example, now I'm again running it on one simple file. You can imagine this as you can replace one single file with a directory which has multiple files, where might be the telecom company was already collecting data for a couple of months and they would like to analyze this, and you can run it in this way. So once this is done, we have our output, which can be seen by going into the directory saying sample mr output 2, and again this would have gone for one single reducer. So we can look at whatever we gave as an output. So it was sample mr output 2, and that is my directory. So since this is a directory, my cat command does not work on it. You need to give the file. So the command is by giving the specific file, not by giving the directory. So it is cat sample mr output 2 / part -r, and then you can give 5 zeros, and that should be my out, which should give me an information of which were the users or which were the phone numbers which made calls greater than 60 minutes, and if these calls were STD calls, and what was the duration of the call. So this is how you can use MapReduce programming model to solve your real-time business cases. Always remember, you have to code and create your mapper and reducer function, and rest will be done by the framework. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.